Welcome to lecture series on database management system. In today's lecture series, we are going to see about concurrency control and various problems associated with concurrency control. So, as we have discussed in earlier presentation about what is concurrent access. So, when more than one transaction is executed or it is happening simultaneously, we call it as concurrent transaction. So, main problem associated with concurrent transaction is the lost update problem. That is, one transaction will lose the update. One transaction couldn't keep track of the update which is made by the other transaction. It is called as lost update problem. Here, please look at the example I have mentioned. There are two transactions, T1 and T2. Here, T1, the transaction T1 is updating the balance. Is updating the balance. So it is obtaining the balance from account B and it is updating to the balance. Now, again, transaction 2, when it reads the balance from the same account B, and if it sets the balance, it reads as 220. Now, again, transaction T1, it sets the balance, it will become again 220. And now it is withdrawing the balance. So, after withdrawing the balance from account A, it becomes 80 rupees. Now C withdraws the balance. It becomes 280 rupees. Here, the transaction T2's update on the shared object B is lost because already transaction T2 has updated the account balance of B as 220 rupees. Now again, if transaction T1 is updating, so the amount should be greater than 220, but it still remains as 220 rupees, which means transaction T1 lost the update which is made by transaction T2 on B. So this is called as lost update problem. Another one is inconsistent retrieval problem. This happens due to partial or inconsistent transaction. If the result of one transaction is incomplete or partial, and if it is retrieved by other transaction, it is called as inconsistent retrieval problem. Now look at the example given. Account balance of A is 100, B is 200, and C is 300. Now transaction T1 withdraws 100 rupees from account A. So initial balance of account A is 100. After withdrawing the 100 rupees, the balance becomes 0 now. Now transaction T2 reads the balance from A. So what will be the balance? It is 0 rupees and it is updated in the total. Now again transaction T2 reads the balance from account B. Initially the balance of account B is 200 rupees. So when no other update is made to it, so when it reads the balance, it is obtained as 200 rupees. Now the total is 200. Now transaction T1 is depositing 100 rupees in B. So what is the balance in B? Initially it is 200 rupees. After depositing 100, it becomes 300. Now, T2, transaction T2, it receives balance from C and it is adding it to the total. Initially, the total is updated as 200 rupees. When it reads the balance from account B, total is updated as 200. Now, after obtaining balance from C, it is 300. So, 200 plus 300 would be 500. But is it correct? It is wrong, right? Because after after T2 reading, see, look here, I'll highlight and show you. Here, after T2 reads the balance of B as 200, sorry. Transaction T1 has deposited 100 rupees in account B, but that is not updated in the total. So, which means T2's transaction is not reflected in the total, which is updated by T1's result is not updated in the total, which is done by T2. So this partial result is T1's partial result is used by T2, which gives the wrong result. Why? Because actually at last the total has to be 600 because the balance of account B is updated as 300. So total should also be updated to 300, but that is not done. So this is inconsistent retrieval problem. Next is a serial equivalent, checking if two transactions are serially equivalent or not, which means two transactions, if they are performed sequentially in same order, two concurrent transactions. I'm talking about two concurrent transactions. If they are performed serially in order and if it gives the same result when they are performed concurrently, then those two transactions are called as serial equivalent. Now see, the same balance is updated in account A, B, and C. A with 100, B with 200, and C with 300. Now transaction T, so this is a concurrent transaction. But just by looking at the example, you should be able to tell if it is concurrent transaction or serial. Because more than one transaction is happening parallelly, so it is concurrent transaction. Now T1 is trying to get the balance of account B. What is account B's balance? It is 200 rupees. So B's balance is said to be 200 and balance is updated by balance into 1.1. Now it becomes 220. So transaction T1 is completed, which is, and then again it is followed by transaction T2. Now, transaction T2 again gets the balance of account B. It is 220 and it sets balance by balance into 1.1. Now it becomes 242. Now, transaction T1 withdraws the balance from A. So balance into 0.1. It is withdrawing around 20 rupees from account A. Now balance becomes 80 rupees. So 100 minus 20 will be 80 rupees. Now transaction T2 again withdraws 20 rupees from C. So 300 minus 22 becomes 278. See, all the transactions are completed. All the transactions are completed before other transaction begins. So there is no lost update problem here. There is no inconsistent retrieval problem here, which means both the transactions, though it happens serially, will produce the same result as to when they are executed concurrently, which means here transaction T1 and T2 are serially equivalent. So far we have seen what is concurrency control. We have seen two problems under concurrency control, like lost update problem and inconsistent retrieval problem. And we have also seen how to check if the two transactions are serially equivalent or not. So hope you understood. In the next lecture video, we will discuss with some other transaction related topics. Thanks for watching and keep watching.